look at radical equations, and here's a great example of one. I want to solve here the square root of 4 minus x equals 2. So if you're asking yourself, what is a radical equation? Well, a radical equation is an equation that involves radicals, square roots, cube roots, fourth roots, etc. Before we solve this equation, we need to look at some sort of warning here, because consider this example. If I started out with x equals 6, now let's just suppose for fun I square both sides. So I get x squared equals 36. Okay, so if you're taking notes at home, I squared both sides. Alright, now to solve this equation, x squared equals 36, what I want to do is take the square root of both sides. Okay, so I'm taking the square root of both sides. I'm going to write it like this. Square root of x squared equals the square root of 36, but when I write in the square root of 36, I have to put plus or minus. So I end up with x equals plus or minus 6. Now, think about this. I started out with just x equals 6, and now all of a sudden I end up with x equals plus or minus 6. So what happened? Okay, the problem is right here. When I square both sides, there's a possibility that I may generate an extra solution. We saw that happen in this example. Alright, so when I took the square root of the equation squared, I end up with a negative 6 as an answer as well. Alright, so going back to this first example, we have to take that in consideration. Since there's a square root in this equation, we know that I'm going to square both sides to get rid of that. But when I do, I may generate an extra solution. Let me show you how to solve this. Okay, so I'm going to have the square root of 4 minus x equals x plus 2. I try to isolate my radical. Now what I'm going to do is I'm going to square both sides. So I'm going to have 4 minus x equals x plus 2 quantity squared. And you know what? Let's make an asterisk here, because we need to remember that I squared both sides of my equation, and so I might have generated a solution where I shouldn't have. Okay, so here I have 4 minus x equals x squared plus 4x plus 4. I got that by foiling. This is now a quadratic equation, so I can easily solve it by getting 0 on one side. So to do that, let's see how to add an x over, so it becomes 5x. And I had to subtract a 4 over, so I end up with a plus 0 here. Okay, so I can factor this equation by taking out an x. This is greatest common factor, take out an x, and I have an x plus 5. So I end up with solutions x equals 0 and negative 5 as my two solutions. Now, because of my warning here, is what we've done over here, I think maybe I should try to check my solutions. And actually, I am going to do that. So let's check to make sure that these work. Okay, so first let's check 0. If x equals 0, and I plug it in my original equation, I end up with 4 minus 0 in square roots minus 0 equals 2. Okay, 4 minus 0 is 4, and the square root of 4 is 2. Minus 0 is 2. So I end up with 2 equals 2. That works. Okay, so 0 is a solution. Alright, so let's check negative 5. And I think we're suspicious of this one now, but let's just check to make sure. So if I plug in negative 5, I have the square root of 4 minus a negative 5 minus a negative 5 equals 2. Okay, so 4 minus a negative 5 ends up being 9. So the square root of 9, which is 3, minus a negative 5 becomes plus 5 equals 2. So I end up with 8 equals 2, which we know does not happen. So the negative 5 does not check. So the negative 5 is what we got here. When I squared both sides, I generated the negative 5 as a solution. So my final solution then is x equals 0. Or if you want to write it as a solution set, it's the set with only one element, 0. Okay, now all radical equations work in the same way. I want to show you a couple more just to show you the caveats. If you have any questions on them, as always, please let me know. Let's take a look. Alright, so for this first one, I have the square root of x plus 1 plus the square root of x plus 2 equals 1. Alright, so I have two radicals in this situation. So what I want to do is try to get the radicals separated at least. So I'm going to bring 1 over to the other side. So let's say 1 minus square root of x plus 2. Okay, and from there, this is not perfect, but from there I'm going to square both sides. Okay, and let's put an asterisk on this because we know now there's a possibility we created an extra solution in doing this. Okay, so the square root of x plus 1 squared is easy. That's x plus 1. Right? The second part, though, don't say that's 1 minus x plus 2 because that's not true. I have to FOIL this out. So if it helps, visualize it like this. 1 minus square root of x plus 2 times 1 minus square root of x plus 2. So you have to use FOIL method here. So when I multiply the first terms, 1 times 1, I get 1. The outside terms, I have minus square root of x plus 2. The inside terms are also minus square root of x plus 2. And then lastly, I end up with a plus square root of x plus 2 squared, which is just x plus 2. Okay, so now I can clean this up a little bit. Let's keep the radicals on the right-hand side and move everything over to the left, okay? So I'm going to subtract my x here, and I'm going to subtract a positive 3 over to the other side. So that means all of my x's zero out, and I have 1 minus 3, which becomes negative 2, equals negative 2 square root of x plus 2. So let's divide both sides by negative 2, end up with 1 equals the square root of x plus 2. Wait a minute, I got another radical equation, okay? Well, that's okay. So if we know to solve radical equations, we're going to do what? We're going to square both sides again, and maybe I need to put in another asterisk there. Okay, when I do that, I end up with 1 equals x plus 2, which implies that x equals negative 1. So this time I only got one solution, but we do need to check it. Okay, it's possible that this equation had no solution to begin with. So let's let x equal negative 1. And let's plug it in to our equation. So if I did that, I'd have negative 1 plus 1 under square root, plus the square root of negative 1 plus 2, and hopefully that all equals 1. Let's think about it. The square root of negative 1 plus 1 is 0, and negative 1 plus 2 is 1, its square root is 1, equals 1. That is a true statement. Okay, so negative 1 is a solution. If you want to write it as a solution set, that's going to be negative 1 in braces like that. Let me show you one more. Okay, this time in part B, we have the cube root of 3 minus 2x minus the cube root of x plus 1. And again, I'm going to try to isolate these radicals as best I can. So I'm going to add over the cube root of x plus 1 over to the right-hand side. Okay, and we're going to change our strategy a little bit. When I have square roots, to get rid of the square root, I need to square both sides. Okay, because one way you can think of that, if you remember, is the square root of x is the same as x to the 1/2 power. So when I square both sides, I'm taking 1/2 power to the second power. That means I multiply powers, which gives me x to the first. So when I square a square root, it does cancel out in some way. Here, to get rid of a cube root, which is the 1/3 power, I need to do what? I need to cube both sides. So I'm going to cube both sides. And when I do that, I end up with 3 minus 2x equals x plus 1. Okay, now I just have a linear equation. So let's move our x's to the right and our constants to the left. So I'm going to subtract 1, end up with a 2. And when I add the 2x over to the right, I end up with 3x. So I end up with x equals 3/2. Okay, now, do we need to check this? Well, I didn't put my asterisk in here, right? Actually, this one I don't need to check. So if I have odd radicals, there's no need to check my solutions, okay? For even radicals, square root, fourth root, sixth roots, etc., we do need to check them. Okay, the reason goes back to the beginning. Remember, if I had x equals 2, for example, when I square both sides, and then I take the square root of that, I end up with a plus or minus 2 in this example. If I cube both sides, though, there's only one cube root of 8, and that's positive 2. Negative 2 cubed does not give me 8, right? It gives me negative 8. So with odd radicals, you get unique solutions here. So x equals 3/2 is my solution. If you want to write it as a solution set, you can say 3/2 in brackets like that. Okay, radical equations are not too difficult. The only thing is, students forget to check solutions. And so I try to make that clear in these examples. If you have any questions on this, I'd be glad to help. Let me know, and thanks for watching.